Graph the solution to the following system of inequalities. X is less than or equal to -4, y is greater than or equal to -5, and 4 times x plus 5 times y has to be less than -15. All right, well, I'm going to go ahead and start this one by graphing the first two systems, or the first two inequalities, because they're pretty straightforward. So if x is less than or equal to -4, that means that I'm going to have a vertical line at -4. So I'm going to go ahead and just make a vertical line there. And it has to be solid because it says less than or equal to. And because it's less than, that tells me I'm going to be on the left side of it, since the x values to the left are definitely less than the x values on the right. Okay. Now let's look at the next one. Y is greater than or equal to -5. So I'm going to go to -5 and put a horizontal line. And this one also is going to be a solid line because it also has an equal to component. And we have to shade above this one since we want the y values to be greater than this line. So everywhere above this has y values greater than -5. So we now know that we're going to be somewhere in this rectangle here. Okay, it all depends on our last line where we're going to shade. So let's do the calculations for our last inequality. It's in standard form, and we want to get it into slope-intercept form. So let's go ahead and move the x term to the other side. And then let's divide by the coefficient. So we're going to get y is less than -4/5 x minus 3. All right, so let's go ahead and come over here. -3 is the y-intercept, and the slope is -4/5. So from the y-intercept, I'm going to go down 4 spaces and to the right 5 spaces, because that's going to produce a negative slope. And I'm going to be careful here when drawing. I want the y-intercept, and I want this point here. All right, and so be really careful. Sometimes you think, oh, there's a triangle, I should shade the triangle. Okay, we already know that this triangle does not contain the solutions because we know that we have to be on the left-hand side of this vertical line. All right, so our only options, all right, we know that we have to be on the left-hand side of this vertical line, and we already said that the y values have to be greater than this horizontal line. So that means we're either dealing in this area or we're dealing in this area up here. Those are our only two options. And let's look at this inequality. All right, the first thing I notice is that it's a less than, which means that I need to make this line a dashed line. So there we go. Now it's dashed. And less than. Will these points contain y values less than this line, or will these points contain y values less? Well, we know that we have to shade underneath because that's where the values would be lower. And so this is our shaded area. And so all of these would be solutions to this system. Okay, every single one of them would be a solution. And now Alex only lets me put tick marks on the actual grids, but of course the reason it's shaded in is because when you have an infinite number of points all crowded into a space, you start to not be able to see the individual points, and you just see a shaded area. Okay, so any point in the shaded area is a solution. I also want to talk about a couple other things in this. Because this is a dashed line, no point along the dashed line is a solution, right? Dashed lines don't count, but solid lines do. So anything along here would be a solution, and even a point along here would be a solution. The intersection of the two solid lines would be a solution, but would the intersection of a solid and a dashed line be a solution? Well, no, because it wouldn't satisfy the dashed inequality, okay? So in order to have an intersection be a solution, it needs to be the intersection of two solid lines. All right, there you go. I hope this was helpful. I'm going to go ahead and press check just to prove that we got it. And there it is.